Good evening, everyone present here. So, welcome to week 11 of online discussion on course that is wastewater treatment and recycling. The instructor of this course is Professor Manoj Kumar Tiwari from IIT Kanpur. My name is Manitam Prakash, and I am also from IIT Kanpur, a PhD student in environmental engineering. So as usual, we meet on every Tuesday from 7 p.m. to 9 p.m. using the link which has been already shared with you. And the recording of this session is being uploaded on this YouTube channel. So if you have any kind of doubt, you can just go back and check. So in week 11, we will be dealing with these five topics. So till now, we have seen that how wastewater is treated at different stages, and we at each and every treatment we focus on one thing, that is efficiency, because depending upon the efficiency, the water which has been treated can be reused. So can be reused or can be discharged at some place. So in this discussion we will be looking into that only, that how that water can be reused or recycled. So I hope you are aware of the term reuse and recycle. Like recycle means it can be converted into some other forms. So like initially, and reuse means like we are using that same thing for again and again. So if we want to give an example related to water, so suppose there was one drinking water, and after its use it has been converted into wastewater, and after treatment again it has been treated at such a efficiency that it can be again reused for drinking purpose. So this will be considered as the water has been treated in a such a way that it is being reused. But now consider that we are recycling means we are converting into some another form. Like initially it was for drinking purpose, and say after treatment we are using that water for irrigational purpose, so we have recycled that water. Okay, it's not that good example, but you can just imagine what is reuse and recycling. So we will be looking into that. Then we will be looking into different opportunity, like what are different ways to recycle and reuse. Then we have requirements, like why we are reusing or recycling our wastewater. Okay, then some of the guidelines, like there are, we have been always looking into this thing. If you are attending my session, I have always focused on these things, that we have to design our wastewater in a such a way that it meets the government rules and regulation. Every government has set some rule and regulation. Pollution control board is there, then world health organization is there, they all have set some rules. So we have to treat our wastewater in a such a effective way that it follow those guidelines. And finally we'll be discussing about something called decentralized and centralized and decentralized recycling. Okay, so this common slide is there for every session. Like we have already discussed about this primary, preliminary, primary, secondary, then we have advanced. And each and every stage we know that there is sludge production and there is some water. So that depending upon what is the purpose of that treatment plant, so we know that suppose the water is, suppose at some places means no such high amount of treatment is required, and suppose organic matter is very less in that water. So what is generally practiced, that the water will be allowed to settle in primary sedimentation tank, and the water will be directly allowed from the treated water which has been generated here. There are high chances that it can be discharged to some places directly from primary sedimentation tank. It's all depend upon the efficiency of the primary sedimentation tank and the quality of wastewater. Similarly, if high organic matter is there, then it will go to secondary treatment. And suppose we have some advanced, like a specific purpose, like for drinking. Then we have to look into removal of dissolved organic matter, dissolved suspended solid. Then there are different things. So depending, all depend upon the reuse and recycle. Okay, now. So see, discard. So I think all of you have gone through this lecture. So in the actually last two sessions are fully whatever type of numerical and all this thing was there to discuss. We have already discussed in previous lectures and all. So it will be these lectures are kind of informative lectures. Like you have to know these things. It's not like that one a subject is there only to solve numerical question and all these things. So there are something which you should know so that you can explain others in a better way. So I this thing has been already shared with you. So I have taken these slides in little bit like if you have gone through these slides then it's good. Not no, if not then just we will go one by one on each and every topics. Okay, the first thing, what is the concept of this wastewater? If you have any kind of doubt, you can just ask in chat box, or you can just unmute yourself and you can start speaking. Okay, now. So okay. Hmm. So the concept of wastewater reuse and recycling focus on utilizing treated wastewater as a resource rather than discarding it as a waste. So reuse itself means itself has a meaning that we are not discarding that water. We are just reusing for some other purpose and all these things. This practice aims to address the growing pressure on the water resource by reusing water for various purposes, this thus reducing the overall demand of fresh water. We know that for a particular area, either they are dependent upon some kind of river or they are dependent upon the aquifer present in that area. So we know that those resources have limited water. We cannot always rely. So we have to find an alternative, and we know that uh, we most means we generate huge amount of water. We generate huge amount of wastewater with the means by just simple use. So one best way not to not apply any pressure on the resource, that we should start reusing the wastewater by treatment. So that's why they are like it's written that to address the growing pressure on the water resource, we have there is some pressure on this, that it has limited resource and all this thing. Okay, so coming to this wastewater, so this pressure, this refers to the process of using wastewater for different application. There are two. So this thing we have already seen, and there is one thing called recycling. In a recycling, water is processed and treated to make it suitable for reuse, often in the same system where it is generated. Okay, so we are recycling water. Recycling is a process, reuse, both are process. There you must have used of reduce, reuse, recycle. So as similar to this solid waste, the same term are being used for water also. Okay. Hmm. This process refers to process of using water for different application. There are two types of reuse: direct use. Treated water is directly supplied to use for activities such as irrigation process or domestic non-contact application like toilet flushing and all this. So, if you have recall our previous lecture, then there was one discussion like what is the best way to manage our waste. So there we have also talked about this thing, and you might have seen some practice also that in toilets what people are doing, that they are reusing same water for flushing and all these things. So they just don't want to waste too much water on too much fresh water for flushing our toilets, and that's all. Similarly, for irrigation purpose, I have given you example of many location. One location is in Kanpur only, that we have one treatment plant. and there is a very huge canal going from that canal to several village, and that water is being used for irrigation purpose, but that water has itself some kind of problem, but this practice is being followed. Okay. Then there is this indirect use. Treated or untreated wastewater is released into natural body like rivers or aquifers, which is often then used as water resource for for additional treatment. This is commonly done for groundwater recharge. So direct use, I have said you that irrigation, industrial, and all these things. Then indirect use is that after some degree of treatment, what will we do that we will discharge that water in some kind of river or some kind of pond, so that will help in re- recharging our aquifers and all these things. So this is commonly the groundwater recharge. So just we are recharging, so we are not directly reusing it, we are indirectly using it, so that's why it is known as indirect reuse. Then there is this waste recycling. In recycling, wastewater is processed and treated to make it suitable for reuse. Often in some system, it is where it is generated. This involves water reclamation. Okay, the treating water to remove contaminant and making it fit for reuse. Often for non-potable water like irrigation, industrial cooling, or even potable application. In so we are just recycling it. We are we are not directly making it like we are just reusing for some other purpose, so that is recycling. Okay. And the main question is, so see, all these are connected, like you have to connect the dots, like why we are recycling, why we are reusing. And simple answer is that we have limited resource of water, fresh water, and many activities starting from drinking to irrigational purpose or agricultural purpose. This is used, this fresh water is used, so there is a huge pressure on this fresh water. So we have to do something, and the best way is recycle and reuse. Okay. Purpose: to conserve water, reduce pollution, and manage the growing demand in agriculture, industry, and domestic sectors. Treatment level recycling often require multiple treatment stages such as preliminary, primary, secondary, and advanced to meet the quality of a standard for different application. Okay. Suppose we want to we want to treat for agriculture purpose, then there is no need of such advanced treatment. Suppose if we want to treat for drinking purpose, then we have to meet some other standard, then high degree of treatment is required. Okay na? So you just remember, you have to keep two three things in your mind. One is there is one guidance is there, you have to treat, like first you have to identify the problem, like what is the final purpose of treatment. So this our problem is this type, this will be our statement that we have to say reuse our water for agricultural purpose or irrigational purpose. Then we have to go through the norms which is set by pollution control board or agricultural board, whatever we there. And and we have to treat our wastewater according to that rule and regulation. Okay na? So depending upon that, the, we will be having different level of treatment. What is the benefits? Benefits: they reduce the strain on the freshwater resources, prevent environmental degradation caused by untreated wastewater. We have seen that if we throw our wastewater, then it will just cause degradation to existing water, fresh water, and all these things. Provide a sustainable and cost-effective water resource for potable use, non-potable uses. So depending upon the fresh water for irrigational purpose is not a good option. So it's better to reuse the wastewater after some treatment and all these things. So here in detail again, what is the indirect use? Indirect use involves treated or to augment the natural water resource like groundwater recharge, or just we are recharging our groundwater. It is natural age-old practice where treated wastewater enters the river or lakes and eventually get reused. Okay. Then we have to be focused on direct use, because eh, we have to actually both is see this recharge purpose, recharging and of aquifers is a like time taking. So we have to like yeah, it's time taking, and it has been reported that it's not so much efficiency or efficient also. So people are more focused on this direct reuse. So wastewater is treated and then directly piped into a specified use. Depending upon the level of treatment, it can be applied for domestic use such as toilet flushing, irrigation, gardens, or cooling. So here it is written non-contact because they are just they are not drinking it, not bathing it for with the help of this water. But if the degree of treatment is such that it has removed all the pathogens, all the contamination also, then there are high chances that it can be used for contact means drinking purpose and all these things. Then they industrial use for process like cooling, boiler, feed water, or washing. Irrigational use, that is for agriculture, especially a species species sorry non-food crops or in landscaping. So they are different there are different way where we can reuse our water. Potential areas of application are, then we have discussed about which kind of water can be recycled. It's not like that every kind of water can be recycled and all these things. So the most common recycling has been done in India, is not in India but at every place, is of gray water. Okay, so gray water which comes from non-toilet, because it is very easily see a huge amount of gray water is being produced. That huge amount of non-toilet domestic source like which comes from non-toilet domestic source like sinks and showers. A huge amount of water from bathing, for cleaning, from cleaning and all these things. A huge amount of water is being produced. It is easier to treat since it has a lower pathogens, because we know that organic content in these water generally we have detergent, then we have urea and all these things. So organic content in these waters is very less. Okay now, not urea also. We are talking about non-toilet. Okay now. So this makes it ideal for reuse. So a huge amount of grey water is produced, and this is the most easiest form. This water can be easily recycled. Okay now. Then we have municipal sewage water. We know that it contains huge amount of organic waste. Municipal waste requires a higher degree of treatment but can be effectively reused in agriculture, landscaping, and even some industrial purpose. While it poses more challenges due to higher organic matter and pathogen, it can be significantly resource when appropriately treated. Okay. Then industrial effluent recycling. Industry can reuse treated wastewater with their plants, reducing their dependency on fresh water. So we know that see if you like mhm, this industry, we know that there is boiler and all this thing, and they require to cool off the boilers and all this thing. There is always need of some water. So it is suggested that in those industry can reuse that water or recycle that water. Okay na, which has been already used once. A storm water or river rainwater reuse. Collected storm water can be used for irrigational, street cleaning, or other non-potable purpose, offering an additional source of water for urban areas. Okay. Then sector for reuse. So here we were seeing about recycling or reuse. Okay, now then on which sector this water can be on what are different places where this water reused, this wastewater can be reused. So, in agriculture or aquaculture, treated wastewater can be used for agriculture with varying level of treatment level depending upon whether it's for food or non-food crops. It can be used in fish farming or other aquaculture operation. So, this statement itself stand for itself that uh, we have seen this is a common practice that it will be released through canal and water will be used there. Municipal sector treated wastewater can be used for public park irrigation, landscaping, firefighting, and even non-contact places like toilet flushing in household and commercial buildings. Then industry in for construction, floor washing, and fire protection. Environmental sector treated water can be utilized to augment natural water body like a stream flow, enhance or artificial groundwater recharge. So these are different way via which we can use our uh, use our wastewater. Then another point comes of opportunity with treatment. So this thing is again repeating itself. Like if we reuse water, then it can be used in agriculture purpose for food, both food and non-food crops and all these things. Then then all these are different places where what wastewater can be reused. Then benefits of wastewater reuse and recycling is that it is used in pollution control, water conservation, cost saving and sustainability. So we know that if we reduce wastewater discharge into natural water bodies, helping control water pollution. Water conservation is there that provide an alternate water resource, reducing the demand of fresh water supply. Then we have cost saving. Recycling treated water can reduce the cost associated with freshwater procurement and wastewater discharge. Okay. Then sustainably contribute to sustainable water management, particularly in water scarce region. So see, actually there was no question, numerical question related to this thing, but I have taken some internet source and I have just tried to generate one question. So just we will go through like this is like cost comparison, like depending upon the efficiency at different plant and how much we are spending on fresh water and how much we are spending on wastewater treatment and which one is good or better. We will be looking into that. So an industrial facility produces this much of wastewater which is treated for reuse in three stages. First is primary treatment is there and the water is being collected from here for reuse again from secondary. Here also the water is being used. Tertiary, after tertiary treatment some water is being used. Okay, now the plants aim to reuse as much as water as possible for its process. Okay, so they just want to reuse as much as water. So for that they have constructed a primary treatment that has efficiency of 85% in reducing suspended solid and larger particles, and 15% of the wastewater volume is lost in the form of sludge. We know that every time sludge is being produced, which is a combination of solid and liquid, so out of suppose this much water is coming, so 15% is being converted into sludge. Okay, now 15% of the wastewater volume is lost in the sludge. Okay. Similarly, in the secondary treatment, there is efficiency of 90%, but and 10% of the volume is lost due to microbial digestion. Okay. And similarly, in the tertiary advanced chemical treatment and all these things, 95 efficiency is there, and 5% of the volume is lost in the final filtration process. Okay, there is some loss at each and every stage. Okay, the plant consume this much cube of 5 rupees per meter cube to supply fresh water, and it 25 meter cube per meter cube for each stage of water treatment. Okay, na. So so this they are when they are supplying fresh water, this much per meter cube, this much water is getting consumed, and at each stage for 1 meter cube of this much amount of money is spent. The energy cost of pumping treated water back to facility is 2 rupees per meter cube. The plant required itna meter cube for its operation. Okay, na. uh, hmm. So here see, we have some question like what is the volume of water entering remaining after each treatment stages. Will the facility meets its daily demand? So see, the plants require this much for operational purpose. This much of water is being required. So they are just asking after this, after we if we are reusing it, will it meet the demand of this much? this much meter cube after wastewater reuse, or they have to be dependent upon other sources also? What is the total treatment cost if the facility can only use water that goes through all three process? So they are assuming that we are not externally supplying any kind of water. So what will be the cost? What is the total cost saving compared to the using fresh water, including the energy cost of the pumping? So we will be looking into one by one. So in primary treatment, we know that this much water, this much is coming 85% efficiency. So water after primary is only this much meter cube. And we know that we have, first we have primary, then we have secondary, and finally we have tertiary or advanced. Okay, PST, primaries, secondary, and tertiary. Okay, na. So water entering here 5 meter cube, 5,000 meter cube water is entering after passing through primary sedimentation tank. The water will be only 4250 meter cube. Here also there is a loss of 10%. So the water after secondary treatment will be this much meter cube. Okay, na. And tertiary treatment, there is efficiency of 95%. Okay, na. So 5% is lost. So the water which is entering this leaving this secondary treatment will go to tertiary treatment. And after tertiary treatment, we have only 3.755 meter cube. So this was our first question, that what is the volume of wastewater remaining after each treatment. Okay, now. So, and the question was, there was another question that for its working, the plant required this much of meter cube of water. Okay, now. But after treatment, we have this much meter cube of water. So yes, the facility can meet its water demand. So the facility don't have to depend upon the other sources. Okay, now. The treatment cost at each stage is this much meter cube. So therefore the cost of treatment of the wastewater through the three stage will be just multiply the volume at each stage. And then we have final cost treatment as this much amount, that is 32600, 875, that is 3,26,000. Okay, 3,26,875 per day. Okay, so for treatment of this water, but see, remember, it's one thing is that this water is not dependent on external source for their operation. So we will be looking into further more questions just to answer that, is it a good option, yeah, bad option. Okay. So the total volume available for reuse is this much. Okay, if the plant had reused water for this, the cost will be this much. Okay, so remember, we know that to supply the fresh water, this much meter cube, 5 per rupees per meter cube is used. Okay, now. So this is what here written, that this is total cost of treatment 3 lakh rupees. And the plant has used fresh water for this volume. The cost will, if it is being used as fresh water, then this much amount of will be required. Okay, the pumping energy is this much, 2 rupees per meter cube. So to pump this much of water, this much amount will be required. So total operating cost will be treatment plus pumping, that is 3 lakh plus 70 to 200. So that will be this total, this much cost. The cost of reusing water is, again, we know that the cost of reusing water is this much. Okay, so the net saving will be fresh water cost minus operating cost. So here you can see that the fresh water, we can see that in operating this system, we are investing too much, 5 lakh. But for fresh water, we are just getting fresh water from fresh water. We are just getting 5 rupees per meter cube. So we can see that there is no net saving, or we are even in loss. Okay, now. So this indicates no cost saving, and instead a higher cost due to energy and treatment expenses. Okay, so see, at one point, the plant is not dependent upon any fresh water or any external source of water, but on other hand, the whole operation is very costly. So now see, it's not always like that we have to look into every aspect. So this is not economically a good option, because see what if the treatment plant goes down one unit, suppose there is one unit which is not working properly, so there is need of what do we call as a maintenance. So there should be some money saved for maintenance and all these things. But with the help of this calculation, we can see that there is no cost saved for maintenance, so it won't be a good option. So there are several way to optimize it. Either we can decrease the operating cost, or we can increase the freshwater cost and all this thing. Okay, na. So these are something we have to look. Okay, na. And coming to another topic, that is potential and why we are means, like we have already seen that why it is required, and the answer is simple, that we have limited amount of wastewater. Okay, the potential for the wastewater reuse and recycling is immense, particularly in regions facing water scarcity or high demand for non-potable waters. However, successful implementation depends upon the meeting several requirements that ensure safe, efficient, and economical viable reuse. Here is a detailed breakdown. So here you can see that we will be looking into different aspect, that why it is required for or what is the potential for wastewater treatment. So in India, for example, nearly two-thirds of sewage is discharged untreated, representing vast untapped resource. Globally, the amount of wastewater generated is substantial, making it a promised candidate for water reuse. Theoretically, 80 to 90% of water used in in household, industry, and agriculture can be recovered as wastewater after accounting for losses during treatment. 70 to 80% of this water can be reclaimed for reuse. Okay, na. So we are producing a huge amount of wastewater, so it is always like instead of depending upon this fresh water, we can always look into this recycling and all this thing. Okay, na. So we know that there is need of agricultural purpose, need of industrial purpose, the need of some municipal. So instead of depending on fresh water, we can just reuse our wastewater and all these things. So treated wastewater can be reused for landscaping, agriculture. We have already seen this. Then another potential of wastewater is that environmental benefits. So now suppose imagine that there is a lake beside your home, and you are discharging your wastewater in that lake. After several years, maybe after 2 years, 3 years, you will be start realizing that the condition of that lake is not so good. So that is being degraded. Okay, now. So that's why it is always suggested that whenever you are discharging, just treat your wastewater, or uh, mm, 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 treat your wastewater, or just reuse that wastewater after some kind of treatment. Recycling wastewater significantly reduce pollution by preventing untreated wastewater from being released into river, lakes, and other natural bodies. And we all know that if untreated wastewater is thrown into the lakes, then there is something called eutrophication might happen in that lake or river. So we don't want that, because that will just degrade our lake with time. Okay, it contributes to environmental sustainability by augmenting water resource like aquifers. So it also helps in recharging our wastewater. Another thing is why it is required. So there is, initially we were discussing potential, like if we treat water, then what we can achieve. Then another question is uh, what is the requirement. Okay, na. So requirement for wastewater recycling, so first it should meet water quality standards. Okay, na. So we know that, suppose in our mind that we are fixed that this water will be used for drinking purpose, then we should just define what are the things required for that treatment. Okay na, so at what degree of treatment we should go, so that you can reuse that water for drinking purpose. Okay na. So appropriate treatment for wastewater to be used, it must be treated to meet a specific water quality standard for intended use. That is, intended use means a specified use. Different application, like suppose if we want to treat for agriculture, use for agriculture, then we should be treating in that way, and whatever the required instrument or required facility is there to treat our water for the agriculture use, then that must be available. Okay na. Require different level of treatment ranging from secondary to tertiary treatment. Then there are regulation and guidelines, which I've said you, like pollution control board, government, international body like WHO, organization like USEAPA sets a strict regulation for water use, ensuring public health and environmental protection. For instance, WHO, as so see, it's all dependable. It's all saying that if you are treating your wastewater and the water which is being released, and if you want to reuse that water for some particular purpose, then it should meet some guidance. Okay. USC EPA guidelines outline water reuse category and requirement treatment for each use. So similar to WHO, we have this US EPA that also states some regulation, and it should meet that requirement. Okay na. Just 1 minute. The USEPA stand for US Environmental Protection Agency. Okay na. US means US United States Environmental Protection Agency. So in India we have center CPCB. Okay na. In India we have CPCB, Center for Pollution Control and Board. Pollution and Control Board. Center for Pollution and Control Board. Okay na, CPCB. So they have all defined pollution and all these things. Reliable treatment process, like again this is like it's not like that we have intention of reuse of water for agricultural purpose and we don't have any reliable treatment process, then there is no need of treatment and all these things. Okay na. The consistency in treatment, the treatment system must consistently produce water that meets required quality standard regardless of variation in wastewater composition. Reliability is critical for public health and environmental safety. Technology adaptation. Treatment technology must be adapted to local condition and needs. For instance, in area where electricity is scarce, low energy treatment option must be applied. Okay na. So suppose I am planning to construct a treatment plant in village, and the purpose of the treatment plant is to, after treatment, the water will be used for agricultural purpose, and we know that we have one problem of electricity in general in village. So and we know that for treatment purpose also there is requirement of pump and all these things. So we should be making sure that treatment is being such a way that it's not always dependent upon the, that it's not like that a huge amount of energy is being wasted on the treatment and all those things, so that might be causing a secondary pollution. Okay. Economical feasible should be there. Advanced treatment process such as membrane filtration or chemical treatment can be costly. Project must be financially viable over long term, particularly for large scale recycling program. So the cost, we have seen that if the cost, uh, we have seen one example where the treatment was not cost effective. Energy cost means like not a huge amount of cost should be, energy should be wasted. Okay na. Recycling system require energy, particularly for process like pumping and advanced treatment. The energy footprint should be considered. Sustainable practices could be improve overall feasibility. Okay. Then after treatment, there is another requirement for wastewater treatment is infrastructure. Okay na. The wastewater must be efficiently collected from its source and transported to treatment facility. After treatment, distribution network are needed to supply the reclaimed water for to point of use. Okay, na? So either there should be some pipeline or proper canal should be there from beside the agricultural field and all these things, so that water can be easily circulated from this channel to this field. Okay. Hmm. In some areas, treated wastewater might be stored before use, which required storage. So again, a statement itself explain what is the purpose of a storage and all the thing. Another problem with this wastewater. Suppose if someone comes to your home and they said that the water which we are the wastewater which is was produced by me will be after treatment, it will be supplied to our home for some maybe some purpose. So generally people avoid those things. So this is just a mentality of people, like they means like they just don't depend, they just don't want to do it. So it can, so there should be some public aware, like the water which is being treated safe to use, can be used without any hesitation and all these things. So this is like a, again, now suppose I plan to treat water for drinking purpose, and when we are supplying nobody is using it, so then there is no point of treatment and all these things. Now suppose in a village I constructed a treatment plant for irrigational purpose, and people are not using that water just because it was wastewater. Okay, na? Even though it is treated wastewater, people are still not using because at some point that water was wastewater. So we have to make people aware that things like what is the degree of treatment, like how secure and how good is that water for their use. Okay, na? So social awareness and acceptance. Successful reuse program depends on public willingness to adopt recycled water, particularly for potable uses. Clear communication about the safety and benefits of treated water is crucial to overcome any stigma associated with wastewater. Okay, na? Educating committees, industry and farmer about the benefits and safety of recycled water can improve the acceptance and encourage adoption. So this is required. This is all things are required for recycling or reuse. Okay, now without this, no wastewater can be reused and recycle. Okay, then we have to consider environmental also, like protection of nature, like in process of recycling, we are not degrading our environment. Also, the recycling of wastewater must ensure that it does not harm any natural water bodies, either by introducing harmful contaminants or by overloading the environment with treated effluents. Environmental impact assessments should give guide all the projects. So it should meet all the regulation, and there should be some authority to check on those thing. Okay, na? So it's not like that we are treating one thing, we are treating wastewater, but at some point we are degrading our another part of environment, maybe water, air and land. Okay, na? So it should be checked. Increasing awareness of emerging contaminants such as pharmaceutical, endocrine disturbing compound is crucial. Advanced treatment may be necessary to remove these substance, particularly for potable use. Okay, na? Institutional capacity, regulatory framework, proper governance and oversight are needed to monitor the wastewater treatment facility and ensure there. So there should be some. Generally, it is happen that suppose for our in Jajmao case, it is like IIT Kanpur is maintaining whatever. It's like I don't know the exact detail, but at some point it was said that all the treatment plant and all this thing was constructed by IIT Kanpur only under the guidance of some professors here also. So I'm not sure about that, I might be wrong here also. Okay, na? So so that's why a proper always like initially how much efficiency of that water is there, is the water being treated has consistency and all these things. So it should be always checked. Okay, na? Funding and support. Government must provide funding, guidance, and support to ensure the wastewater recycling system are implemented effectively. Without institutional backing, projects may fail due to inadequate maintenance. So I said you that a proper funding should be there, or else what will happen there? There is no maintenance, cost, and all these things. and we might face a loss and all this thing. For a city aiming to recycle municipal, so this is just a example of requirements, like what is the different requirements in municipal sector wastewater recycling project. Okay now, for city aiming to recycle municipal wastewater for park irrigation and industrial use, the project would need treatment plant capable of producing water meeting the required standard for the irrigation purpose. Then pipeline should be there to transport the treated water to public and industrial zones. Acceptance public campaign to address the irregular monitoring. So you can see this thing. Okay, na? So so hmm. So uh, what I was saying that. We know that there are different agency. So yeah, we have WHO, that is World Health Organization. Then we have this US EPA. In India, we have this CPCB. Okay, now so we will be looking into these. What is the different regulatory guidance for wastewater reuse and recycling? Okay, now the wastewater is guidelines for treating wastewater reuse and recycle ensure that treated water is safe for public health, meets the environmental standard and is fit for its intended application. These guidance are developed by international organizations like the WHO, US EPA, as well as national and regional authorities. Here is the detailed explanation. So we have this. So actually, I am speaking continuously, speaking for 45 minutes. So I will just stop, take a break here. Not a break, but I will just. So if you have any kind of doubt, just ask now. Then I will go into details. It's not related to this topic. If you have any Subhas, Akash, if you have any kind of doubt, you can ask. Or if you want to discuss anything else, anyone? No. Okay. Just wait for 1 minute. Actually, my health. I'm not in a good health today. Just wait for 2 minutes. Don't go anywhere. sorry for that. Actually, I have some health issue. I'm not feeling well today. That's why I have to go. Hmm. So what I was discussing that what I was discussing that every means there are some rules and regulations and that are being set by some body, that is WHO, USCP. In India we have CPCB. So we'll be looking. So WHO guidance focus on safe reuse of wastewater for agricultural and aquaculture application. These guidance establish microbiological and chemical safety standard to minimize health risks associated with use of untreated or partially treated wastewater. Okay. Key criteria is microbial quality. WHO sets a standard for acceptable limit of pathogens like bacteria, viruses in wastewater, particularly for agriculture or of crops that are consumed raw. Okay, na. So chemical quality, the presence of any heavy metals, persistent organic pollutant, and endocrine disturbing compound. That is, medicine treated water must be minimized to prevent harm to soil, crops, and human health. Monitoring, continuous monitoring is required to ensure that the reused water consistent meets the set guidance. Then we have USCP guidelines like the United States Environmental Protection Agency, or simply EPA or US EPA, provides comprehensive guidance on water reuse, focusing on municipal wastewater for irrigation, industrial application, and even potable reuse. Okay, na? So key criteria is the USCP define the minimum treatment standard for different type of reuse, ranging from secondary treatment suitable for non-potable users to tertiary treatment required for potable users. Criteria for reuse: the USCP define the types of reuse, including unrestricted reuse for educational of food crops and landscape area where public access is frequent. So they have defined some rules for this thing. Then restricted reuse for application where limited human exposure like golf course, irrigation, or industrial process. Okay. Then we have direct potable reuse, then indirect potable reuse. So they have defined different type of reuse: unrestricted, restricted, direct potable reuse, indirect potable reuse. Direct potable reuse: treated water is introduced directly into drinking water distributed system and after advanced treatment. Then we have indirect potable reuse: treated water is discharged into natural water bodies and then later it is withdrawn for potable. Okay, now so till now we were just looking into two types: direct reuse, indirect reuse. But this USCP has defined into four different types: unrestricted, restricted, direct, indirect. Okay, now the risk assessment. The USCP focus on minimizing the risk of contaminants like pharmaceutical and personal care, which has emerged as a potential hazard in. So they have also focused on the emerging contaminants that we have seen. So if we look into in India we have already said that we have one thing: CPCB regulates the wastewater reuse in India, ensuring the treated water meets the standard for irrigation and industrial use. I will show you also this thing, so you can have an idea. CPCB. Eh, see here. Now suppose there is one some treatment plant. I hope you are all able to see my screen. So suppose if there is some treatment plant, and so the wastewater can be either can be discharged on surface water, or it can be discharged in public sewers, or can be used for irrigation, or can be discharged into coastal areas. Okay, na. For that there is each and every parameter, like uh, starting with the color. So there should be some particular color, then the amount of suspended solid should be this much. If suppose say I'm talking about irrigation purpose, okay na, then the maximum suspended solid should be 200 milligram per liter. Then we have pH should be 5, between 5.5 to 9. Temperature, there is no such thing mentioned about temperature. Then this much should be oil, this much should be chlorine, ammonical nitrogen should be this much. See here, there should be no nitrogen in any form. The COD, BOD, which we biological oxygen demand. Okay, the which we have talked for irrigational purpose is should not be more than 100. Then I, I don't know, there should be some limit for COD also, because if BOD is there, then there should be some COD also. Arsenic should be this much. So you can see that there is a limit for each and everything. If that is being maintained, then that water can be discharged into that particular area. And it is generally, at some places it is being followed, at some places these are not being, they are not being followed. Okay, na. So it's all dependent. So there are many report, you can just check it, like how guidance and analysis. So see, this is also a report by CPCB only. I don't know, is it I think it is also for, it is for CPCB only. So here also you can see that in this report I think they have given a uh, like how sample was collected and how different analysis was done. Okay, na. Similarly, we have zero liquid discharge ZLD policy enforced in many industry, particularly in water-intensive sector like textile and pharmaceutical. This mandates complete reuse of wastewater within the industrial facility. Okay, the Ministry of Jal Shakti promotes water reuse in agriculture. So there is something called Ministry of Jal Shakti, which just encourage. So these all three are different body which regulate the wastewater treatment in India. Okay. Then in Australia, similar to Australia, we have similar to India, in Australia they have this Australia National Water Quality Management Strategy, that is NWQMS, provide a strict guidance for wastewater reuse, focusing on managing water scarcity. Public health safety is prioritized. Please zoom the slide. 1 minute. Is it okay? Suhas.
Most are different people. When layout is all different.
Hello.
The layout is different.
Is it visible now?
It is not visible.
I don't know what to do. It's maximum. Like I have zoomed 100%. It should be visual now.
It is very small. I will try to restart.
Okay, now it is out. Just restart. Is it visual now?
Yes, it is visible now.
Okay, okay. So similar to Australia, we have in Singapore, they have something called direct potable with its new water program, which reclaims wastewater to drinking water standard using advanced membrane filtration. So we know that Singapore have like very rich, so that's why they are investing in advanced treatment. They are using membrane filtration, and with the help of this membrane filter, they are just reusing their wastewater for even drinking purpose also. Okay, now Singapore regulatory framework emphasize multi-barrier approach, while multiple stage of treatment are combined to ensure safe drinking water. So they are mainly focused on this drinking. They are converting all the waste to potable water. Okay, so when we are looking into guidelines, suppose now suppose if you are working in an industry, and you have to follow some guidelines, so there are something which you should look into it. The first is microbiological standard. So this thing, regulatory framework usually sets microbiological standard to minimize the risk of disease caused by pathogens in wastewater. These standards vary depending upon the type of reuse. So see here in this report, if I look into, you will see that depending upon our reuse, suppose if I want to throw water in land or there, so there will be different limit. So see, order non cadmium for pathogens, it will be in the form of coliform. Okay, na bioacetate. So I think this one is there, bioassay test. You can see that 90% of survival of fish after 96 hour, 100%. So I don't recall coliform cadmium. So it's not. I think I might be looking into some other forms, but remember there is like. There is limits for everything, that if you are discharging, then this much should be that limit and all this thing. Okay, now I'm not able to find right now, but there is limits on biological parameter also. Okay, now water quality parameter. Okay, so I will just I will I'm not able to find right now, but you should have an idea that there should be some microbiological standard and all these things. So then we have chemical standard. With this, we have already seen that several metals is there, like arsenic, chromium, cadmium, and all these things. So there it should not be exceeding, because that will directly or indirectly affect our human health. So suppose it is getting contaminated in soil, then it will be contaminating it will be destroying our soil also. Then we have also seen that nutrients, the presence of nitrogen and phosphorus will be causing eutrophication. then persisting organic matter, they can accumulate in the food chain, posing a long-term environmental and health risk. Okay, na? So this is another problem, that suppose some chemical is there and that is getting accumulated, so it will be causing another problem. Then treatment requirement, we have already seen that primary treatment, secondary treatment, tertiary treatment, depending upon what kind of use. Generally for non-potable use, that if we don't want to drink, we just want to discharge for irrigational purpose and all these things. Generally, secondary treatment is more than required. Okay, na? We only go for see here also we see for irrigational crop products. You can see that there is tertiary treatment, but that also depend upon like what kind of crop is there. Okay, na? So it's all relative. Then again we have discussed this thing that people should be made aware that this water can be reused and all these things. Okay, and institutional capacity, so there should be some reporting and all these things, like one should be always checking that wastewater is being treated in a good way or not. Then coming to this important topic, that is centralized versus decentralized recycling of the wastewater. So in name itself suggests there will be central recycling facility and there will be decentralized recycling facility. So I will be going into both into one by one. While when considering the recycling of the wastewater, two primary systems are often discussed: centralized and decentralized recycling system. Each approach has its own advantage and challenges depending on the factor like scale, cost, environmental impact, and feasibility. Let's explore the key difference between the two, their features, and where they are most applicable. Okay. So centralized wastewater recycling system. A centralized system involves the collection, treatment, and reuse of water at large scale treatment facility. Okay, na? Yes, see the term large scale. Often located far away from the point of wastewater generator, it serves large urban area in industry and municipality by managing the wastewater of entire community. So here, this is the most common thing which we have seen. So what will happen that suppose this is a village, there are thousands, or any urban area there are thousand house in that village, all are producing, there will be, so what will be happening that all the wastewater generated from this home, this town will be getting collected at one point and it will be treated here and again it will be discharged. So here you can see that all here initially wastewater from different location was being collected at one point. So that's why it is known as centralized, that we are treating all the water at one point, so we are centralizing the system. On another hand, decentralized is involve the collection, treatment, and reuse at the near point of treatment. Suppose this is my house, I will be building one small treatment plant near my house. So, but after whatever the waste is being collected, will be going through this treatment, and we will be treating our wastewater. So here you can see that this system can be applied to individual household, a small community or industry that do not rely on large or centralized network. So this is the basic difference. Okay, now. So we will be looking into detail what is the different key features of centralized and decentralized. Hmm. So collection wastewater from multiple source, household, industry, and commercial facilities collected through intensive sewer networks. We have seen that there will be sewer networks and all they will be collecting wastewater. Treatment, the facility collected is transported to centralized. So this is our home, this is our community, thousands homes are there. It will be centralized to, it will be transported to centralized treatment plant. Okay. Typically handle large amount of wastewater using advanced treatment technology, primary, secondary, and tertiary. Reuse or disposal. After treatment, the recycled water is either reused for application like so. What will happen that after there might high chances there is a river, or so water will be discharged into that river, or what will happen that a canal will be formed from this treatment plant, and it will be discharged into that canal for agricultural purpose. Or the there is another option that treated water is again supplied to household for maybe if the treatment level is very high, then for drinking purpose, or then for non-potable purpose. Okay, now economic of a scale. A decentralized system can treat large volume of wastewater at relatively lower cost per unit due to economic of a scale. It is more efficient in densely polluted urban areas. So we know that if a huge amount, a large population is there, then this will be a good option. Okay, advanced treatment, centralized facility can invest in advanced treatment technology, making them suitable for handling a wide range of contaminants, including those from industrial. So as we know that when we are collecting a huge amount of waste, then there are high chances that a new contaminant, a large number of contaminants will be there in wastewater. So depending upon the funding and all this thing, and generally they have this much amount of money, so that they can just treat their water in advanced level. Okay, now decentralized monitoring and controlling, again it should be following some rules and regulation. Okay, now disadvantage is there. There are some disadvantage also. High manufacturing cost is there, so you can see that suppose for a whole Kanpur city there you are, I'm just giving one example there. Like for your whole hometown, suppose there is small village or small hometown of 1,000 house, so you can see at each house there will be some production of wastewater, and they are getting collected at one point. So treating that much amount of wastewater will be costly and all these things. So a large amount of facility, so building those facility is a challenging work and cost. A huge amount of cost is required. Energy, so to operate the different units, a huge amount of energy is also consumed. Environmental impact, large centralized system can have negative environmental effect. So we know that. So these are all known to you. Examples: a large metropolitan city might have a centralized treatment facility where wastewater from millions of people are treated. The treated water can be used for irrigation or discharge into river or ocean. Then we have discharge. We have all seen this key feature is on-site treatment. Wastewater is treated close to where it is generated, either at household level or in a small community. A scalability, decentralized system can be very vary in scale, from a small system serving a single household or building to a larger system handling the wastewater of a community or individual park. Localized reuse, the treated water can be reused locally. For example, for we have seen all these things. Okay, again it will be opposite of centralized thing. As it is a small, we know that we have to treat my only my waste, then there is no such cost investment. So lower infrastructure cost, since the decentralized system do not require extensive sewer network, they are less expensive to install and maintain, especially in area with low population. Mhm. Flexibility, decentralized system can be scaled up or down depending on the needs of the. So again, see, if you are treating for the millions, so you have to make sure. We have seen that first we have to do forecasting, and we have to make sure that this much amount of water can be treated. But for decentralized system, no such thing is needed. We can see that we can just analyze that from my home this much amount of water will be discharging, this much amount of water will be going. So we can build depending upon those things. Okay, environmental benefits, by treating and reusing water locally, decentralized system reduce the need for long distance transport, thus reducing energy. So and minimizing the environmental footprint. They can also maintain the biological cycle by recharging groundwater, so we can see that there is some environmental benefits also. So there are, for larger system, there are high chances that at some point the wastewater might fail to operate, and we are not treating our wastewater in a good way. So that thing will not happen here, since the decentralized system are spread out. One failure in one unit cannot be affect the entire community. Issue can be isolated and deal with locally. Okay, but there are some disadvantage also, that it cannot treat huge amount of water. Okay, now a smaller system may not have the capacity or technology to deal with the complex contaminants compared to the centralized system. Maintenance decentralized system often require regular maintenance by homeowners or local authority, which may be neglected, leading to the system failure or poor water quality. Public health risks: inadequate maintained decentralized system can pose public health risk if the water is not treated to required standard. Okay, so these are some common disadvantage. Example is that a residential housing complex in suburban area may have its own on-site wastewater treatment. The treated water could be reused for irrigational or toilet flushing within the complex, reducing the reliance on the external water supply. Choosing the right system, like whether you have to choose centralized or decentralized, depend upon the population density. In rural or suburban area, the decentralized system can be more practical, but for dense urban area, this centralized system it will be most cost effective. Cost consideration: centralized systems are more expensive to build but can handle larger volume at a lower cost per unit in long run. Decentralized system had lower upfront cost but may require more regular maintenance. Environmental concern: decentralized systems are often preferred for lower environmental effect, especially in area where localized reuse can help recharge groundwater or reduce long distance transport. Technical capability: for treating wastewater with complex contaminants, centralized system may be necessary, especially in industrial setting. However, decentralized systems are often for residential wastewater and can be designed to meet local reuse needs. So, depending upon these things, we can choose. Okay, now the first option is always like the most important factor is first option, population. How much population is that area? Okay, now then we have to look into cost, then we have to look into environmental concern, then we have to also look into technical capability. Okay, so these all were like different short notes from video lectures. Okay, now so I hope this was good for you. I hope this will help for your examination. So some, oh, you ask any particular format for mains. So as from past experience, the format will be similar to your assessment. So there will be theoretical question, there will be numerical question. uh, yes, this slide will be uploaded. These slides are always uploaded. Please check your mail. These are being sent to you. Okay, na? So, so the format of the exam will be similar to the question which is being asked to you uh, in during assessment process. Okay, na? So just we will be looking to some question. This thing these all questions are very easy question. Among the different type of wastewater, easiest to treat and recycle is, please everyone, please try to do the gray water. Yes, correct answer. Because this does not control. Hmm. Yes, D is the correct answer. We know that grey water contain very small, very low amount of organic matter. So it only consists of inorganic matter. The refers to the generated from domestic activities such as washing dishes, laundry, bathing, excluding toilet waste. Black water contains human waste and is more complex and challenging to treat due to higher level of pathogen. So this grey water is correct answer. Talking to the other process, municipal sewage encompasses both grey water and black water, making it more difficult to treat than grey water alone. Industrial wastewater can vary greatly in composition, often containing toxic substances and high level of pollutant, making them more difficult and costly to treat. Okay, now then we have for treatment process, it is this grey water can be simply treated by filtration. Okay, na sediment and biological treatment. Grey water usually have lower concentration of pollutants such as bacteria, nutrients, and black water. Black water treatment require more advanced. We have already seen this thing. On another hand, so these are all like different. Mhm. Different point which I want to make that out of these four type of water which can be treated easily. So due to its lower contaminant level, simpler level process, and higher recycling potential, gray water is considered the easiest type of wastewater to treat and recycle compared to the industrial wastewater. Okay. Coming to the second question, the impact of wastewater recycling and reuse on freshwater resources include impact. Just remember, I have discussed each and everything. So this question can should be answered very easily. The impact of wastewater recycling and reuse on fresh water include improve water quality of freshwater resource, reduce water from withdraw from. What will be the impact if we start reusing C, both A and C? Yes, correct. So we know that if we start extracting less fresh water, then its quality will improve and reduce the water withdrawn. Obviously, we will be more using our wastewater, then fresh water will be as it is. Okay, the correct answer is B. That is both A and B. The correct answer is C. C, both A and B. Improve water quality. Wastewater recycling can reduce the load of pollutant entering the freshwater system, leading to the improved overall water quality. Improve water quality from wastewater by reusing treated water for various applications. The demand of the freshwater is decreased. Sorry for that. The demand for fresh water is thus reducing the withdrawal from natural resource. Therefore, the wastewater recycling and reuse positively affects both water quality and the quantity of freshwater resources. Okay, now match the following. This thing also we have discussed: indirect use, direct contact use, direct non-contact use. Try to answer it. What will be indirect use? match the wastewater use and their example. So indirect use, we were saying about groundwater recharge and all this thing. Oh, BCA, huh? So yes, so we'll be looking into it. Indirect use typically involves using treated wastewater to replenish groundwater. Hence, it matches with B. Direct use involves using treated water in a way that directly come in contact with the human, such as supplying water to swimming pool, hence matching with the C. Then direct non-contact refers to the using treated water for non-potable application where there is no direct contact with humans, such as irrigation, hence A. So the correct answer is BCA. That is B. BCA. B, C, and A. Okay. Good. Coming to the fourth question. Try to answer it. Which of the these driving factor for wastewater reuse and recycling is directly linked to financial implication? Environmental and social responsibility, regulatory requirement on wastewater treatment and disposal, easy accessibility of wastewater as an alternate water source. We have D, all of these. Okay, so let's look. The correct answer is B, not D. All of these is not correct answer. While this factor may influence decision related to sustainability more ethical consideration than direct financial implication. Okay, na. So see this, so environmental and social responsibilities like making people aware, and so environmental public, we are just in treating wastewater, we are uh, not damaging our environment. So these are not related to money and all this thing. Okay, now regulatory required of wastewater compliance with often even so see now a government has said that your BOD should be 100 milligram per liter, and so you have to invest money to make sure that whatever the BOD coming in your system, suppose wastewater which is coming into your system is 1000 milligram per liter, and you have to reduce to 100 milli, so you have to invest that much, so that from 1000 milligram per liter to 100 milligram per liter it can come. So it's all depend upon the cost. Remember, why we are not using membrane, but it is most effective, because it's all about cost. We have seen that in removing solid, membrane has highest efficiency. If you have attended my last session, we were discussing about membranes and all this thing. So here there we have seen that membrane has highest efficiency, but that is being very that is very costly. So people are not able to use it in a smoother way. Okay, now easy accessibility of wastewater agent. This may reduce the cost, reduce, but not directly to financial application. Like so, the correct answer is B only. Okay, now I hope this is clear to you. It was asking about which is linked to financial implication, where we have to invest more, due to which region we have to invest. So we have to maintain the criteria set by government. We have to make sure that whatever kind of water is coming, we are treating at a such a efficient level that that is making sure that all the parameters for particular intended use is being fulfilled. Did you get it, Subhas?
Yes, okay, okay.
Coming to the fifth question, just solve this question. I'm coming in 1 minute. So we have two option: a standard one, a statement one. Under indirect potable reuse scenario, treated wastewater is first stored in environmental buffer. Indirect potable. Whenever we are talking about indirect, then we are talking that it will be used for recharge and all this thing. Okay, na. So first statement is correct because first we have to keep in environmental so that it just helps in recharging. For direct potable reuse, treated water may or may not be stored in engineer stored buffer. For so let's see what it's saying. Huh. So, in indirect potable, the treated water is indeed a stored environmental water such as reservoir or aquifer before being reintroduced into the potable water supply. The buffer allow for additional treatment and natural process to improve water quality. Okay. Hmm. So this is a correct statement. The statement to indirect treated water can be directly supplied. Obviously, there is no need to store. If your treatment level is high, then you can just directly supply the water to uh, consumer without storing it. So, indirect potable reuse treated water can be directly supplied to the potable water system without environmental buffering. However, in some cases, an engineer's storage buffer may be used for additional treatment or operational flexibility. Therefore, statement is correct as it acknowledge both possibilities. Okay, na. Since both the statement, the correct answer is C. C. These are both one and two. Coming to the question, this thing I have also this thing just if you have gone through the slide, you will be you can answer approximately percentage of water is recycling 70 to 80% of water consumed. Okay, na. So this is like knowledge thing, no science in it. Okay, na. This was the answer for this will be B, 70 to 80%. Coming to the question number 7, try to answer it. Guidance of the use wastewater is released by. So the correct answer is C. Okay, na. So just remember what different organization do. Okay, na. Such as this FAO is Food and Agricultural Organization that concerned about food and agriculture. Then BIS Indian Standard Code, like for different standard codes is there for water, construction, and all these things. So that is, and then another thing is that CPEHO, Center Public Health and Environmental Engineering Organization. So it's related to health and all CPHO. CPHEEO. Okay, now so that has another purpose. But this for wastewater, this WHO has set some rules. So the answer for this question is C. This was also very easy. Coming to the question number 8, which of which of this pollutant is most difficult to manage when planning wastewater treatment for reuse application? Just go through. Just this is also a very common question. I think you so. I will be waiting for some time for answer. Which of these pollutants is most difficult to manage when planning wastewater treatment for reuse application? A. Emerging contaminants. Yes. You see, conventional things can easily remove nutrients, suspended solids, COD, BOD. But these emerging contaminants are very difficult to remove. So this is most difficult. Okay, na, right now. Emerging contaminants, these includes pharmaceutical, personal care products, and other chemicals that have recently been recognized as pollutant in environment. They are often present in very low concentration and can be resistant to conventional water treatment process, making them particularly challenging to manage. Their effect on human health and environmental are fully understood, and a specialized treatment method may be necessary to effectively remove them. These can be easily removed. For example, while nutrients like nitrogen and phosphorus can cause problem, but they are typically more manageable with steam treatment plants. Suspended solid beneath primary sedimentation tank is there. For COD, BOD, there we have secondary treatment. Overall, the answer is A. Coming to the question number 9, pollutant threats of reusing water without treatment for agriculture application. Potential threats of reusing water without treatment for. So I have not discussed something about SAR, sodium adsorption rate ratio. So just let me show you what is this sodium SAR. So see, no, this SAR, that is sodium adsorption ratio, is defined as sodium divided by concentration of sodium divided by calcium plus magnesium divided by 2 under root. This is more simple. So this is how SAR is defined. So it is like so government has set some rules at that for see here water class. If the SAR is less than 10, then water is excellent. If Miss water is excellent for educational purpose. Remember, if SAR is less than 10, then water can be used for educational purpose. If it is between 10 to 18, it is good. And if SAR is greater than 26, then that water cannot be used for agricultural purpose. So this SAR is used in agricultural field. Okay, now it is just to define like I hope you have understood. Like if the depending upon these SAR value, uh, that water can be used for irrigational purpose or not is defined. Okay, now SAR greater than 26 is generally not considered for agricultural purpose. Okay, now so the question is question is if SAR is which of the following without any treatment, if water is being used for agriculture purpose, what problem can be? Surface loading could make the soil hydrophobic and water repellent. So we know that oil and grease are there in wastewater, and if it is being discharged in agricultural, so what will happen that it will make the soil very bad, and it might not be productive also. Then we have ACR ratio in soil may rise, making it suitable for agricultural. So remember, suppose a water is coming which contains high sodium and that is getting penetrated in soil. So what will happen that soil, a huge amount of sodium will be there, magnesium and calcium will be there. So overall, what will happen that it will increase the SAR value. And SAR, if SAR is high, then what will happen that it is not good for our soil purpose. Soil coliform may be transmitted into harvested. Obviously, coliforms means harmful pathogens. So what will happen that pathogens may be getting transmitted into soil, maybe getting transmitted into food, and that will be indirectly or directly contaminating us, or making uh, it will be not good for us. So the correct answer is D. The make so here whatever I have told you, it's written here. It's written here. The surfactant loading could make the soil hydrophobic, and soil surfactant found under accumulating soil leading to hydrophobic contamination that reduce water infiltration may rise in suitable for agriculture. Using water sodium can leading to the higher sodium. See, high sodium is there. Generally, high sodium is there in our wastewater. Okay, na affect soil structure and making it less suitable for agriculture. Coliform may be getting accumulated into harvested food crops. Untreated wastewater can contain harmful pathogens, including coliform bacteria, which can contaminate crops. Since these all points highlighted potential threats associated with the reuse of untreated wastewater, D is the correct answer. We have another question of statement 1 and statement 2. Reuse of reclaimed water through the treatment in agriculture sector is totally risk free. Okay, now we have statement one. Statement two is agriculture sector reuse of wastewater is most common reuse class around the world. Can you say the reuse water is totally risk free? The first statement is incorrect only. And second, so I will we have less time, so I will just go into the explanation. So the B is the correct answer. The first statement is incorrect. When reclaimed water can be treated to reduce, it is not totally risk-free. There are potential health and environmental risks associated with using reclaimed water in agriculture, including contamination with pathogens, heavy metals, and chemicals that may not be fully removed during treatment. Okay. Statement 2 is also correct. Agriculture sector is not indeed the statement two is correct. Sorry, correct, incorrect. Okay, now and this is the most common. Generally, most in most of the world, the reused water is only for agricultural purpose. Okay, now so the correct answer will be B. B will be the correct answer. Degree of treatment required for agricultural water reuse. See, this is very simple and common question. Try. I'm expecting an answer from all of you. And we have discussed this thing also again and again. It's all depend on which type of crop we are there. Is it for our degree of treatment required for agriculture water reuse vary significantly depending on the several factors, including the type of crops being irrigated, the potential health. Okay, na. So, for instance, some crops are not consumable raw, like certain grains may require less stringent treatment compared to crops that are eaten raw, like fruits and vegetables, which are necessarily high level of contaminant to ensure safety. So, the must decide the based on the crop. Okay, na. So, the correct again this is a knowledgeable question. So the correct answer is for this is uh, B. Correct answer. The correct. So this is this is like you should know. It's like turbidity should be less than 2 NTU, BOD should be less than 10 ppm, and there should not be any coliform bacteria. Okay, na. So this type of question generally won't be asked, but if in class it has been discussed with you, then this type of question can be asked. But so remember, reclaimed water should have urban reuse should meet these parameters. Okay, na. In decentralized system, in decentralized water system, which of the following is correct? Long distance transporter is used. No. In decentralized, very small, we are treating our wastewater near our home only. Operation and maintenance is easier when collectively than decentralized. Yes. Operation and maintenance. The correct answer is B. Statement 1 is incorrect. Decentralized management are designed to treat water close to point of generation with minimize the need of long distance transport. This is one of the one of the key advantage of decentralized system. Symbol B is statement B is also incorrect. While with decentralized system offer certain operational and maintenance, they are not easier to manage collectively than the centralized system. Factors such as community environment. So both the statement is incorrect. I hope this is clear to you. The correct answer will be D. Neither A nor B is correct. Both the statement are correct. D is the right choice. Factors such as communities, so obviously it is in a smaller, but it also depend upon the people and all these things. Okay, not and whether the technology which is used is being people are aware of that thing or not. Okay, now. Second last question, adjacent image represent the case of, so you can see there is a drinking water facility, there is a community, then the wastewater is being generated, then it has gone through advanced treatment, and then it is being stored, and finally again it is uh, being sent to this drinking water treatment facility. So this is like a direct potable reuse of wastewater. We are directly, after treatment we are directly, you can see the flow diagram now. First as waste is generated, then it is being treated, then it is being stored, and then it is being transported to the drinking water facility here, where there will be some treatment, and again it will pass through the community. So this is an example of direct potable reuse of wastewater. Last question of the day, match the wastewater reuse with their correct examples. Okay, so you have joined. Last question of the day, try to answer it. Unrestricted urban reuse, restricted urban reuse, environmental reuse. Okay, so I will be going by one option. So see this thing. Unrestricted urban use, potable domestic supply. Unrestricted urban reuse involves using treated water for potable purpose, such as supplying drinking water. This reuse typically subject to a strict treatment standard. So the first one will be matching with A. Okay. The restricted urban reuse means restricted urban reuse is where treated water is collected, is used in controlled environment such as fenced recreational area or decorative fountains to limit human exposure. So again, it will be matching with C. Then environmental reuse means augmenting water bodies or stream flow. So environmental reuse refers to, remember these parameters were defined by US EPA. If you recall this, if you recall my lecture, we have discussed this thing here. See here, unrestricted use, restricted use, indirect potable, direct potable. So USCP has defined all these terms. Okay, na. So if you that's so so this one environmental reuse will be matching with B, augmenting water bodies into means just we are what we are treating wastewater is um, is left into the water bodies for their own benefits and all these things, because once the water is treated we can just throw it, we can discharge in river so that a sufficient amount of water is in river and all these things. So that's all for today. Anyone have any doubt? We can have we have 5 minutes. Any doubt? We have 5 minutes. We can use that 5 minutes. Thanks, sir. Welcome. So we have more two session left. One will be on next Tuesday, that is 15th, and there will be one extra session on 19th of October. You will get mail of that. So in that session, I will be summarizing all the things which I have taught till day. So it will be 2 hour session. So as usual, please join the next Tuesday session. And on 19th, we will be again meeting for extra class to summarize all the things. Okay, now so so on next Tuesday you can give us a I so does the problem type of question? Yes, there will be numerical question and theoretical. Both type of question will be there. Whatever the in main exam, you can expect the question that were being asked you during assessment. Similar, there will no same pattern will be there. There will be some numerical question. You have to either choose option or you have to answer between range, like numerical. You have to fill the number that this is the answer. Same pattern, no change. Any more doubt? So please do join my next two session. It will be like closing sessions. If you have any question, you can ask or we can end the session. Uh, s- it depend. Like if by solving those assessment, if you have clear your all concept, see question will be revolving around those topics only. It won't be the question which will be there in main examination won't be any new question. Either there will be change of word and all these thing. But if you have solved each and every question in during your assessment honestly, then that is enough. But you have not solved those assessment problem honestly, then this will be difficult for you. It's all depend upon your honesty level, whether that is enough or not. Suppose I am preparing for examination, means one may just go through the notes and all this thing, and one is the depend on how honestly I have gone through the notes, and one is means like it's all depend upon your honesty level. Is it enough or not? I cannot. This cannot be answered. If you have solved it honestly, solved it all the assessment problem honestly, then I can surely say that is enough. You don't have to go. You can expect similar type of question. No new question will be there. Okay, so I think that's any more question, Mahesh Reddy. Okay, okay, so we can end the session here. Thank you for joining. I am ending the session. Please do join next session on Tuesday, second last session on next Tuesday, 15th of October. Tata. Good night.